In this chapter, we'll talk about the idea of controlled loops and random numbers. Oftentimes, we find that we would like to have an algorithm execute multiple times in a row. And so, for example, here I'm printing hello world 5 times to the screen. Well, rather than actually write 5 executing lines of code to print it to the screen, we can use an iterative structure that allows us to use the same algorithm, but then have it run that algorithm 5 different times. So, or the idea of having it just print a number that is going to increment as it prints each time from 1 to 2 to 3 to 4. We will take a look at these basic algorithms as it relates to iteration. Iteration is the process of repeating an algorithm over and over again. One of the things that we need to make sure that we avoid is creating that infinite loop, which never stops and oftentimes can crash the computer. So the first iterative structure that we're going to talk about is the for loop. It is a controlled loop. So a loop is the idea that the computer repeats a sequence of instructions. And so the for loop is used when we know the number of iterations to execute, as in the example of printing hello world 5 times. The for loop is a pre-test loop structure. So what that means is that it will test first to see whether or not it should execute. So the for loop may never execute at all because it's a pre-test looping structure. The 2 keywords that we will use are the word for and next. So let's take a look at what that hello world printing 5 times would look like in an iterative structure. So rather than have 5 print statements, instead I'd use a for loop that says, hey, print this 5 times. So the basic structure of the loop is where we have a counter variable. So for count being initialized to 1, so here we're initializing count to start at 1, and I want you to go to 5. So this is going to start count at 1, and then it's going to increment count to 2, to 3, to 4, and then to 5. And once it reaches the range of 5, then the loop will terminate. So we have an incrementer then that would allow that to happen. So what's going to happen is count's going to start at 1. And so count is within the range of 1 to 5. And so it's going to print hello world to the screen. Then it's going to say next count. So it's going to loop back up to the counter line, and it's going to increment count to 2. 2 is still within the range of 5, and so it's going to print hello world again to the screen. Drops to next count. Next count says, I want you to move up to the next count, which is going to be 3. 3 is within the range of 5, and so it's going to print hello world again. And it's going to drop to next count, or count's going to go to 4. 4 is still within the range of 5. It's going to print hello world, and it's going to go up to next count. Count is 5 is still within the range of 5, so it's going to print hello world again. And then it will say next count. So it will go up to next count, but at that point, count is equal to 6. And so since 6 is beyond the range of 5, at that point, it will fail the body of the loop and drop down to the next executing line of code, which in this case is the end. But what you should note, because this could matter in other programs, is that count actually terminates at 6. So it will have gone 1 beyond. But it is testing to make sure every time I do next count is count within the range of 1 to 5. So let's take a look at that printing of that 1, 2, 3, 4, 5 in our initial slide. So again, we still have our counter loop where we're going to start from 1 to 5, and this can be anything. I mean, I can go from 1 to 10, I can go from 1 to 100, I can go from 1 to 10,000. What I'm asking it to do in this case is just print the value of count. So it starts out by printing 1, then it says next count, so count goes to 2. 2 is still within the range of 5, and so it's going to print 2, and so on until it gets to the 5. It will print the 5, count then increments to 6. And since 6 is outside of the range of 5, whoops, that should be a 5, then it's going to fail at that point, and again, this program will end. I can write the same program in a slightly different way. And then there's a very important line in this program that we hadn't seen before. So we still have the same count from 1 to 5, like we had in the previous two examples. But right here, it's going to let x equal the current value of x plus 1 more. Well, x is not initialized, so x is going to have the value of 0 when it executes that the first time. So count's going to equal 1. And what it's going to do, it's going to let x equal the current value of x, which is 0, plus 1. So x is going to store a 1 in memory. It prints that 1 to the screen. And then it says next count. Well, count is going to go to 2. Well, it says let x equal what is stored in x, which is 1, and add 1 to it. So it's going to let x equal 1 plus 1 more. And so x is now storing 2, so it's going to print 2 to the screen. It says next count. Count is going to equal 3. And so it's going to let x equal the previous value of x, which is 2, plus 1. And it's going to store a 3 and print a 3 to the screen. It's going to increment count to 4. X is going to equal 3 plus 1, which is 4. So it's going to print 4 to the screen. And then it's going to let count equal 5. X is equal to 4 plus 1, which is 5. Print 5 to the screen. Count is going to equal 6. 6 is outside of the range, and therefore it terminates. So we looked at a couple different ways to use the looping structure. We can increment loops using numbers or variables. All right, so where we have numbers here, I can use variables. And the incrementing can be done with a positive or a negative number in the expression. So that gives us a new keyword step. Plus, I can step by different increments than just by 1. Now, by default, next count will increment by 1 if I don't indicate otherwise. But if I want to increment by other values, then I use the word step. So this one's going to start at 1, but then it's going to increment by 2. So it's going to go 1 to 3 to 5 to 7 to 9. So in this case, it's skipping every other number. I can ask it to decrement or go backwards if I want to. So this loop goes from 5 to 1, stepping by -1. So this one's going to work its way backwards from 5 to 1. I can also use a variable in there, letting the user decide, or, based on a certain value, how do I want it to execute? So whatever J value is, F is going to go from 1 to whatever that might be. So there are alternate ways in order for us to increment or decrement through our looping structure. So here's an example of a program that allows the user to decide how it's going to increment. So we're going to start out by entering start as being a 4. We want it to quit at 8. And I ask them, by what step do you want to increment? And so the user enters a 2. And so this one is going to start at 4, and it's going to increment by 2. So we have a 4 here, an 8 here, and it's going to increment by 2, and it's going to print out that count. I want you to notice something a little different from our previous examples. In this line 90, it says print count with a semicolon. That's what allowed for our horizontal display rather than that vertical display. So we can change the way we display it by adding something to the loop. We can also nest our loops together. So that's the idea of a loop within a loop. So a loop embedded inside of another loop, if we recall that for next, we need to make sure that the for next that are related to each other is embedded within the for next of the other one. So we can't have these overlapping lines for our nested loop structure. So what would that look like? So nested loops can't overlap their line numbers. And so that is the example where we had the overlapping brackets. The loop will execute a total of times that is equal to the product of the inner and the outer loop. So here we can see where this embedded inside of each other. So for y is equal 1 to 5, and so next y has to be in there, and then the outer loop are the x's. So x is controlling the outer loop, or y is controlling the inner loop. This one's going to execute 10 times from 1 to 10. The inner one's going to execute 5 times. So this one's going to execute a total of 50 times. So how's that going to happen? So x is equal to 1. So while x is equal to 1, the y loop is going to go through an iteration of 1 to 5. So for x equal to 1, y is going to iterate from 1 to 5. It's going to fail that inner loop, and so therefore it's going to increment x to 2, and y will once again reinitialize and go from 1 to 5. And so then x will increment to 3, and y once again will go from 1 to 5, and so on, with the idea that it will increment 50 times. Using a nested loop is good when I need to control two elements at the same time. And so here's an example where I am controlling the rows and columns of my program. So row is going to go from 1 to 5, and column is also going to go from 1 to 5. And so while row is equal to 1, okay, what's going to happen from that outer loop, and we have our inner loop, is that it's going to print an asterisk. So at row is equal to 1, it is going to print, and you see the semicolon here, it's going to print 5 asterisks in a row in this inner loop, okay? And when it's done executing, okay, it's going to fail the loop when column is equal to 6, and it's going to increment row to 2. So this was while row was equal to 1. So when row is equal to 2, it's going to go through the same process again, where it's going to iterate the inner loop 5 times, printing the asterisk. And then it's going to increment row to 3, and it will print those 5 again. It will increment row to 4. It will print those 5 asterisks again. And then finally, when row is equal to 5, it will print them all again, printing them one at a time. Outer loop has 5 iterations. Inner loop has 5. 5 times 5 is 25. I've got 25 asterisks on the screen. Now, this one actually, if you recall, we have the semicolons going to give me them all in a row horizontally. But I was able to produce a new line. So what happens in this one, this extra line 60 that I have here between my inner loop and my outer loop, okay, it's after my inner loop fails, this print line allows for this new line. It overrides the semicolon, telling it stay there, and actually gives me a new line and allows it to, as I go from row 1 to row 2, it will override that semicolon and move that cursor back to the front of the line. So when it comes back in to print row 2, it's starting at the beginning of a new line. This is a very important algorithm. We will use this algorithm for many things. We will increment through it for many items that we do, whether it's producing a table or actually for allowing multiple inputs. So make sure you have this one written down and you study this nested loop structure.